your cell phone. In addition, the emergency exits are properly marked at the back of the auditorium. In the event of an earthquake, we ask you to remain calm and exit orderly. My name is Angelica, and I will be your Master of Ceremonies this morning. The School of Economics and the Institute of Economic Sciences Research at the University of Costa Rica welcome you to this event, where our guest, James Shortle, Distinguished Professor Emeritus of Agricultural and Environmental Economics at Penn State University, will give a presentation on agriculture and water quality, focusing on the design and implementation of policies and regulations. We begin with some welcoming words from the director of the Institute of Economic Sciences Research, Dr. Juan Robalín.
Buenos días. Quiero darles la más cordial bienvenida a todos los presentes y a los que nos acompañan por el Facebook Live, a todas las personas del sector público y de las instituciones académicas y al público en general. Para aquellos que no me conocen, mi nombre es Juan Robalino, soy el director del Instituto de Investigaciones en Ciencias Económicas y a partir de ahorita voy a hablar en inglés para incluir al invitado. Good morning. I'm honored to welcome you to the seminar, Agriculture and Water Quality, Better Results Require Better Policy, by Professor James Shortle from Penn State University. We are very happy to have you here. Costa Rica is currently facing important challenges in terms of water provision and water quality. It's now a norm that our roads are blocked by people protesting because on a daily basis their supply of water stops, especially during the months of the dry season and especially during El Niño year, as this one. And on top of that, it's very likely that this problem will increase with climate change. Additionally, just a couple of weeks ago, we faced an emergency in some of the most populated areas of the country due to water contamination. More than 100,000 people were directly affected by this contamination. But then when they were fixing the problem, other highly populated areas were also affected. These problems are a reflection of the lack of preparation that we have in terms of infrastructure to address these issues quickly enough, but it also shows the lack of an adequate water public policy. The problem is not just a physical one. It is not only related to the lack of precipitation or to the lack of physical infrastructure. In many instances, as the one we faced not long ago, our challenges are directly linked to human behavior in a context of poor public policy and incentives. Therefore, economics and social sciences in general are required to contribute to the solution of these challenges. Today's seminar is a contribution to this discussion, and I hope this will lead to new research and to better public policies. I would like to thank Milagros Avario for organizing this workshop with the support of our always super efficient staff and for bringing such a stellar speaker as it is Professor Shortle, who is a mandatory point of reference in the topic of water economics. It is difficult to think about a better person than our speaker today to help us explore solutions to the water problems that we face in Costa Rica and in general in this region. It is an honor with a perfect timing to have Professor Shortle discuss about water challenges and public policy. So without further ado, let's continue with the presentation of Professor Shortle by Milagros Saborio. We are eager to learn more about water policy and water economics. Thank you.
Thank you, Juan. For me, it's a little bit beyond words how pleased I am, how happy I am. It's kind of a dream long a dream that I have for a long time to be here in this day and to be able to introduce Jim Soto and to have the honor to hear his presentation and to share his knowledge, which is huge. And it has been an honor for me to be able to work with him, learn from him, and have developed a friendship with him through the years. And I have to thank Adrian Rodriguez, who was a professor in the department, in our department too, some time ago. He was also a student from working with Jim Soto. And I would like to also say that I think the timing is perfect, as Juan mentioned, and I hope we can really think about these issues. We have been thinking about these issues in the academia for a long time. It's not a new thing, but maybe we want to have a new approach. Thank you, and please welcome them with a round of applause. Yeah. Yeah. Excuse me, only wait a minute. Mhm. Sorry, sorry, wait a minute. Today's activity, before the presentation, I talked to you something. Mhm. Today's activity is divided into parts, as you as it is shown in the screen. Mhm. We will start with Dr. Shirtle's presentation, then we will take a coffee break at approximately 10:20 a.m. and we will return for a conversation with our guests at 10:40 a.m. Okay, now, welcome.
Thank you very much. Thank you very much for those very kind words, and it's a great pleasure to meet you because I've heard it about you for many, many years. Thank you for your many kind words, and I appreciate them greatly. And so it is a great honor for me to be invited here by my friends, and very honored and favorite student. It's a great honor for me to be at the University of Costa Rica. I actually came here the first time in 1993 when I was doing some work in Costa Rica, first for the Resources for the Future of the U.S., which is a think tank, environmental think tank in the U.S., which funded part of Adrian Rodriguez's dissertation, in which we developed a CTE model of Costa Rica to look at environmental policy issues. And then over the years, in the 90s, I came back several times and I always enjoyed Costa Rica very, very much. The last time I was here until now was in 2005. Had a wonderful trip around the country with, which is when I met Milagro, and my wife and I had a wonderful time, and we became very, very good friends then. And then she later came to Penn State, where she was at a PhD student with me, and was one who all of the professors really respected and enjoyed very much. So it's a great path for at Penn State and Adrian before. Penn State has benefited from a lot of good Costa Rican scholars over the years in economics and in other areas. So that's been really nice for us. Um, I am kind of in, I don't want to say shock, but the degree of change I've seen in Costa Rica in the last 18, over the last 18 years is stunning. Um, other places I hadn't been before, so that was new, but I've been places that I had been before and I don't recognize them. So a lot of change in this country. And I would say from what I see, it is for the better, which I think is very nice. So my talk today is going to, it has been introduced about policy for water quality for agriculture. Um, and around the world, and especially in the developed countries of the world, agriculture is the #1 cause of water quality problems. Um, so most advanced countries have done a lot to reduce industrial pollution and municipal pollution affecting water. They've done a lot to reduce uh, or with the goal of reducing pollution from ag, but they have failed. And so you find that continuing water quality problems are due to agriculture. Um, and in developing countries, it's an increasing problem to varying degree. Um, so my talk is going to be mostly about the policies that industrial countries have, advanced countries have implemented and haven't done very well with. So my hope is that there are lessons from this that would be of interest in a Costa Rican context. Um, so good policy making is really, really important. My slides seem to be moving themselves. That's good. They're well timed. Um, I for Facebook, do I need the microphone? I do or don't? Oh, I do. Okay. I have a really loud voice. People can hear me. Oh, oh, that one. Oh, this one. Okay. Okay, this slide kind of tells you everything I just told you, but I'll be elaborating. A small advertisement here. This is a book that I wrote during COVID on water quality in agriculture with some colleagues from University of Finland, uh, which has Finland has many of the problems that the US and Canada and other countries have with this. And so it's fun to work with Finnish scholars, especially because it gave me a perspective on other countries' things that I had previously with my North American experience. So kind of an overview of what I'm going to do. I'm going to start off talking about water quality in agriculture, water quality policies for agriculture, which will include a discussion of how they're not working, and then what we ought to do to get better. Um, so this is a picture of a river in the United States in the late 1960s. And this river is the Cuyahoga River, and it is in Cleveland, Ohio. And this river caught fire from industrial pollution in the 1960s. It was so polluted that it caught on fire. That's an amazing thing. And there you see the fire in that river. And when I was in grade school, I took a boat trip down that river. I grew up in the desert Southwest. Water was rare. So as a kid, it's cool to see a lot of water in a river like that that empties into Lake Erie. And this boat trip took us down an industrial corridor of the river where they were dumping untreated sewage, untreated industrial effluent into the river. The river had blue stuff coming into it and green stuff coming into it, all sorts of weird things, and I'm wondering why they do that. And the boat trip driver, tour guide, was telling us about the industrial wonders of this river, factories on the side, the bridges that go over it. And I was kind of, what is wrong with these people? This is just cool. This is not good. And we went out into Lake Erie, one of the big fresh Great Lakes, and there was a huge slime going out into the lake. And so it is this stuff that caught on fire. And it is this kind of situation that led the U.S. in the early 1970s to enact a lot of legislation to protect the water quality. And same thing was happening in other parts of the world. And so this is what the Cuyahoga River looks like today. It looks great. People are out there. I don't know if they swim in it. They may swim in it, but they certainly are out there in the kayaks, and it's pretty. And it's an asset now to the city of Cleveland to have this waterfront where you can have restaurants and cafes and have a good time. So this is a result of policies that the United States put into place in the early 1970s in order to address water quality. But policies were focused on industrial and municipal pollutants, we implemented policies for agriculture. I'll tell you about them more in a minute. The focus really was on what we understood and could see And what we understood and could see was in the industrial and municipal pollution. So when we look at water quality today in the US, the sources are non-point pollution. So you have up there in the left a outfall of stuff coming out. That's stormwater runoff. So washing off city streets, taking asbestos and other things, dust to fall in the streets and the streams. Cows in streams are an amazing cause of water pollution in the US. And then just destruction of riparian zones that you see there. In the bottom two pictures, you have cows and other things that destroy green banks erode, and then they take all the sediment downstream and you have a problem. So you have the non-point and especially agricultural non-point pollution problems. Non-point, it means that the water, the pollution doesn't come out of the pipe, which is a measure of really from runoff or other things like that, atmospheric deposition. So here are two statements from major international organizations. The first one is from the FAO recent study 2017. That says agricultural pollution has already overtaken contamination from settlements and industries as the major factor in the degradation of inland and coastal waterways. So that's really not very old. The same thing could have been said 20 years ago. So it's not a new conclusion, it's an old conclusion. We've understood that agriculture is a big one for a long time, but it's been getting a lot more attention. The next statement is one from the Organization for Economic Cooperation and Development. And basically, it says that the problem with agricultural pollution in the developed world isn't the lack of policy, it's that the policies that have been implemented don't work. So, politicians love to say, oh, we're going to fix this problem and we're going to implement this policy to fix the problem and implement the policy to fix the problem. And a lot of times the problem doesn't get fixed, it gets worse. And then it's time for you to start thinking about how we have better policy. And it's certainly that time for agriculture and water quality around the world. This is an interesting graph that shows the amount of reactive nitrogen. So the kind of nitrogen that can lead to algae blooms in streams or algae blooms on coastal areas, too much nutrients in water. So you see in this graph that in the period since the 1950s, when we learned how to create nitrogen from the atmosphere, the amount of nitrogen that is in the world, the active nitrogen that we have has just exploded. So nitrogen is something that is very bad for water and not too much of it. And it's something that doesn't go away. Once you got it into the environmental system, it stays in the environmental system. So it's something that people call the nitrogen cascade. So we create some nitrogen, we fertilize fields, it moves from the fields into water or moves from fields into the atmosphere as a gas, where it may contribute to global warming or it contributes to the kinds of air pollution problems, and it goes downstream. And so it hangs around. But you see an enormous increase in the amount of nitrogen. The red line there, I'm colorblind, I believe it's red, it could be green. Industrial fixed nitrogen, you see, has really gone up, and that's positive. So that's nitrogen. And then you see that gray bar, and that gray bar is a period of time when scientists around the world began to see huge increases in the eutrophication of coastal water. The big algae blooms, poisonous algae blooms. And they're very tied to this explosion of nitrogen. You look around the world at places where they have nitrogen problems, hypoxic, or coastal areas, places where the oxygen levels in water have gone so low because of decay of plant material in water that there's too little oxygen for fish. Well, it's putting too much living stuff in the water because we fertilized all the water plants, but you have all this dying fish. So lots of places in the world. You see a little bit in this particular diagram, on the west coast of Central America, but not much on the east coast. But if you look at the Caribbean, The Caribbean is going to get a lot of attention from algae blooms because you have the Sargasso Sea, which is getting a lot of nitrogen in it. And then you're getting this, all the seagrasses moving into the Caribbean and they're causing a lot of problems. You see pictures now of these beautiful beaches in Mexico or other Caribbean places where they're having to do industrial level raping to get the seaweed off of the beaches. Some high-profile examples of nutrient pollution, which is the main agricultural problem: Baltic Sea in Northern Europe, Chesapeake Bay. I'm going to talk a little bit more about in the U.S. The Gulf of Mexico dead zone, which is one we pay a lot of attention in the U.S. and some others here. I won't go through those, but there's a lot of places that, from an international perspective, get a lot of attention for these problems. The Gulf of Mexico problem you see here on the diagram on the left, which is the south coast of the U.S. The yellow-green area there are areas where there's toxic, where there's pollution from nitrogen that comes down from the Mississippi River. Lots of problems. One is toxic algae, which can be harmful to people, that can kill fish. So a huge fish kill there. Over there on the lower right side, you see places in Florida where they have these kind of problems. I was telling you about the Cuyahoga River was caught on fire. So on this diagram, you see Lake Erie, which is the lake that goes into, and the lake that got cleaned up in the 1970s, 1980s. It went from a highly polluted lake to a very clean lake, because we reduced the municipal and industrial waste that went into the lake. But now it's a badly polluted lake. The reason is the agricultural runoff that went into the lake. So now it has algae blooms that are terrible. Some of them are toxic. Some of them can poison people when they get to the water supply. So you see the picture there on the left upper side. On the far right side of that picture, you see blue water. Then you go to the line to the left, and you see green water. So that is algae blooms. You see there a boat driving through the algae blooms. That shows you how bad these algae blooms can really be. So I don't know how the boat's making it through it, but anyway, sometimes it's not free on top of water. So these are kind of the kinds of problems we're facing. And this may look ugly, but there's a lot more than the ugliness to it, because it causes a lot of harm to ecosystems in a lot of places. These are the Baltic Sea. Has the same problems. Again, on the right side, you see a nice picture of the Baltic Sea satellite picture. New places where the water is relatively healthy, other places where it has bad algae blooms, and it's sort of the iconic algae bloom in Northern Europe. So on to policies. So I said a few minutes ago that our problems aren't because we don't have policies, but that we do have policies that don't work. So when you look at the developed countries of the world, most of them began to tackle water pollution problems seriously beginning in the 1970s, and did a lot of things to reduce municipal and industrial waste. And in the U.S., we had a lot of places that badly polluted, like the Cuyahoga River, which are now nice because we reduced that pollution. And so a lot of progress there. Water pollution from agriculture, I started working on that when I got my degree in 1981. It was an emerging issue, but not yet a giant issue. But over the years, people, as the industrial pollution went down, the ag pollution went up, water quality in a lot of places wasn't getting good. We began to recognize that it was an important problem. So beginning in the mid-80s, states and the federal government in the U.S. started to pay a lot more attention to pollution control from agriculture. And in the 1990s, we began to develop really big programs to do things about it. And I'll show you that in a minute. And the same was true in Europe. You have many of the same things going on there that you have in the US, Australia, Canada. Um, so, um, so bottom line is we're not ignoring it. We're not doing the same thing though that we did to the other sectors. So for industrial and municipal sources, what most countries do is they put on effluent regulations that limit the pollutants that can come out of the end of the pipe. So you'll have um, restrictions on the concentrations of the pollution or what comes out of your pipe. Or you may be required to install technologies that clean the water to whatever capacities those technologies are required to have. So it's what we call command and control. We tell people what to do, and we tell them how to do it. Agriculture, we didn't go that way. And really nobody's gone that way with agriculture. So what we have done with agriculture is something that I'm calling the agriculture conservation pay for practice model. I invented those words because before I came here, so I've been playing with various versions of this. Partly what we did with agriculture is, so nobody wants to regulate farmers. But I don't know about you. I don't think you probably want to regulate farmers. But farmers tend to be politically powerful. And in the US, farmers are politically powerful, and so state governments and the federal government don't want to alienate the farm vote. So right now we have a presidential election coming up in the US. All the politicians will go, all the people who want to be president will go to Iowa, state of Iowa, to campaign to win the nomination. And if they talk about regulating agriculture, forget it. People in Iowa will not vote for you. If you talk about eliminating ethanol subsidies for corn, they won't vote for you because ag is very powerful. So the approach we take to ag has not been one of command and control. Instead, as we began to look at ag, what the politicians did, and in some ways it makes sense, is we adopted policy approaches that had been used to promote conservation of soil and water on farms. So in the 1930s in the US, we had terrible conservation problems and we had the Depression. And so to fix both the impact of the Depression on the ag economy and to address conservation programs, we developed subsidy programs which would pay farmers to put conservation practice on their farms. So you had these enormous dust holes, enormous dust clouds would blow across the continent of the US from Kansas and end up in New York City and so the model that was developed was to help farmers with extension, educating them on conservation practices, and with the purchase of equipment that help them, plow better and other things, and teaching them about, not plowing up and down the hill, but maybe up and yeah. So this is conservation policy, and it was very effective. So lots of adoption of conservation practices by farmers. And it's good for them because it improves their productivity. It solved resource problems on their farms. So when the politicians wanted to address pollution from ag, they wanted to do the same thing. So the view was that if we provide farmers with subsidies to adopt farming practices that will reduce pollution, it will be beneficial to society. And it will be theoretically, it would be beneficial to farmers. So we provide them with subsidies, we provide them with education and technical assistance to help them do it. So this old conservation model became a pollution control approach for agriculture. And it's not only the US that has done that. Every place that I go to talk about this, they've done the same thing. In Europe, they do it that way. In Australia, in the summertime, they do it that way. Essentially, we pay farmers, pay for practice, we pay them to install practices to reduce pollution from their farms. We provide them with education to encourage them to do it, nudges, as we say in behavioral economics, to get them to do it, and technical assistance to help them with the aspects of doing that. So this is the way we've done it. Key thing is it's voluntary. So farmers aren't told what they have to do. They get to choose whether they do it or not. And some will do it for the purposes of making the environment better. Some of them will do it because practices are beneficial to them, but a lot of them actually don't end up doing it because of the practices of water quality issues. We pay them, we give them a lot of expression about what practices they use, if they choose to do it at all. So it's a very friendly approach to the agriculture. We devote a lot of money to it, like in a minute. There are exceptions. This is for sort of nutrient kind of pollution, soil pollution, those kinds of pollution. Pesticides are generally regulated as we would regulate others. So we have to manage the whole aspect of pesticides. So what pesticides you can use and how you use them is highly regulated in many places. So that's a different approach. The other place where we have differences in the approach is the very, very large confined animal operations where you have pig farms that have thousands of pigs, or you have dairy farms that have thousands of cattle, and where for all purposes you are producing the amount of waste, animal waste, that you have from a small skip. So then you begin to regulate. Agriculture finds that in a lot of places. One other point about what I call the agricultural pay for practice model is that it has multiple objectives. So society has many objectives for ag. So pollution control would be one, and that's a new one. Older ones would be, or contemporary ones would be things like wildlife conservation, making sure we maintain habitat for wildlife rather than buying it up. Reducing soil erosion that reduces productivity. Now carbon sequestration is a big one, biodiversity. So we have lots of objectives that are in programs. So you have programs where they're for water quality, but they're not only for water quality, they're for a lot of other things. So multiple objectives. And I think a lot of us think multiple objective things are good. You know, we all talk about co-benefits, let's do things with co-benefits. But an issue is, might the co-benefits get in the way of the priorities of the program? And they can. This is just the left graph here is the most interesting one. That's how much the U.S. Department of Agriculture has spent on conservation programs in the last 20 years or so. So huge amounts, billions and billions of dollars, and generally increasing over time. The dark blue column on the right side is how much of that is in a particular program that is really focused to a large degree on water quality. The other one's less so. But we have, this is from the federal government only, spent billions and billions of dollars on water quality protection in agriculture over the last 20 or 30 years. So it's not tiny money, it's big money. I want to talk about a particular case, and again, the conclusion is it hasn't done all that much to help with water quality. We have problems, they remain. I'm going to talk about a particular problem, and this is the one that I have worked on a lot in my career, which is the Chesapeake Bay. So there you see some states in the U.S. You know, and up at the top is New York. NY stands for New York. Next one down is Pennsylvania. That's PA. And we have other ones down there: Virginia, Maryland, West Virginia. So Milagro went to school about where it says PA. That's where State College, Pennsylvania, Penn State is. So they don't stay in Boston for a while. She was very cold, but she was there in the wintertime. So the Chesapeake Bay is the third largest estuary in the world, largest one in the U.S. It's very famous in the U.S. It is very ecologically rich. It's a great fishery. It's very well known for blue crab. People love blue crab, pay a lot of money for blue crab. Um, it is, the watershed itself is very large, so 166,000 square kilometers. Um, the water, the bay itself, you see there, the land area, water to the bay itself. So the bay is very shallow. So you have in this area huge volumes of water that are washing across the landscape and then ending up in that small area. Um, and so it just tells you that, you know, what happens on the land is going to be the key determinant of water, a key determinant of water quality in that place. That's what you want to come from. Really degraded by nutrients, so nitrogen, phosphorus, and sediment are the big pollutants. Um, and um, so that's kind of what it is. So when I went to Penn State in 1981, the Chesapeake Bay was just emerging as a very large ag environment water quality problem. And it was getting huge attention. And Washington, D.C. is almost on the Chesapeake Bay. So our federal environmental authorities are there with the bay. They know what's going on in the bay. And a lot of powerful politicians there. So both because of the significance of the bay as an ecological resource um, and the significance of the bay to politicians, it got tremendous amounts of political attention. So it became the focus of major water quality programs beginning in the 1980s. So if you look at water quality policy for agriculture in the U.S., you would say if there's one place it would have been successful, it would be the Chesapeake Bay, because the states have been mandated to do things, the states chose to do things, the federal government has been doing things. Enormous sums of money have been spent there. In 2008, when President Obama was elected, they started a study to sort of gather resources to do better on the Bay. One of the things they did was ask how much federal money had been spent on the Chesapeake Bay to that point. And to that point, with 2008, there had been $25 billion spent of federal money alone against state money to clean up Chesapeake Bay. And it was still a big problem, which is why President Obama started an initiative to clean up Chesapeake Bay, 2008. You've had a lot of things happen to clean up the bay over that time period, almost 40 years now that we've been trying to fix Chesapeake Bay. Now, consistent with what I've been describing, industrial and municipal pollution was drastically reduced in the bay. So this is, so measuring how much pollution goes to the bay is not easy because it's a huge resource. So oftentimes what they do is they model it. So these are modeled pollution reductions between 1985 and 2009. So you see, these are the reductions in pollution, estimated pollution reduction for ag, nitrogen 20%, but for phosphorus and sediment, phosphorus only 4%, sediment 26%. So you'd say, okay, that's nice, we reduced them. Urban runoff, actually, because we grew the human population and the impervious surface area of the watershed actually grew, so it didn't go down and up. But what you have from wastewater treatment plants and combined sewer overflow operations, 41%, 60%, 50%, big reductions in the amount of pollution from those sources. Now, one thing I'm going to tell you is that modeled pollution reductions are, for wastewater treatment plants, they're good. For non-point sources, they're not as good. And we find that these overestimate the actual reductions for that. So they exaggerate how much control we've actually done. So to that point, actually in 1983, they set a goal of reducing ag pollution by 40% by 2000. So here we're looking at 2009, and we have at best half that pollution reduction. So it wasn't getting us where we needed to go. Um, so in 2010, the U.S. EPA said this is a disaster. Things aren't happening that we need to have happen, and they really bumped up the level of control of pollution in the Chesapeake Bay. So they mandated a bunch of new pollution control efforts. Because we've done well with the industrial pollution, they, they didn't get too much attention. Ag was the primary focus of the pollution reduction mandate. So 20 to 25% total reduction in the bay, and most of that coming from ag. So a report came out from the Chesapeake Bay Science and Technical Advisory Committee earlier, late last year, late last year, that said there's been no ag progress. So here we are, 10 years after that, more 12 years after that, everything was supposed to be done by 2025. There's been no ag progress. We're still there, but we spent, again, another billions of dollars on doing the program. Well, we should do something about this because we're not getting any place. We're paying a lot of money. We're not having progress. The politicians, of course, say, well, say the same model. We need more money to do the conservation pay for practice model, but it gets a lot of money. We could know it's not working. So I think it's becoming apparent. I wrote an article in the Chesapeake Bay Journal this year that really pointed out that it's failing, and I got a lot of nasty email and I got a lot of good email. Anyway, so the question you would have now is, you want to do more of the same? Can you fix the approach job for us if you try something new? My argument is that you need to do something entirely new. You have to ask, what would we want to ask when we're doing something new? Obvious questions, I think. Does it work? Is it effective? Well, there's a top priority. We do a lot, but it's not effective, so we're not satisfying that criterion. Farm incomes and rural well-being. This part of the country loves the Chesapeake Bay, but it also loves its agriculture. So you don't want to kill the agriculture. You want to try to find a way to do it nice. Public sector costs. It is really expensive to regulate agriculture because agriculture is complex and because there are tens of thousands of farmers. In the Chesapeake Bay Basin, there are 80,000 farmers. So if you're thinking about regulation and you have 80,000 complex economic enterprises to regulate, you're talking about a big administrative burden. And so I was involved in some work for Pennsylvania's Department of Environmental Protection, which had not been enforcing its mild regulations. The U.S. Environmental Protection Agency said you must begin to enforce your mild regulations, and the state didn't have enough money to do it. It's too expensive. Their budget was too small by regulating all of the farming they would have to do. Return on social cost investment, important. Equitable legal, just things we would like to have there. So I want to dig into why our current approach doesn't work, and then why that. The number one problem is it's voluntary. So because it's voluntary, who chooses to do something is entirely up to them. They don't have to do anything. Unless you're a big confined animal operation, but then you're a small part of the problem. It's the little farmers, actually, the little guys who do most of the freedom because they don't have the capital and monetary skill to actually do pollution control cost effectively. We find the large farms to be the best at reducing pollution cost. So in this case, small might not be better, which surprises a lot of people. But in any case, with this voluntary approach, big polluters that polluters to do a lot may have to do nothing, and you may end up in a system where you're paying people who pollute little to do a lot. That's not going to help you out. That's kind of a waste of money. Practice discretion. So with this approach, the farmers get to choose from a menu like to, like to use on their farm. What do they choose? They choose what's good for them. So they say, I can afford this practice. This practice is actually good for me for these reasons, and I'll adopt that one. You do have farmers who will adopt things that go against their bottom line. But generally, you find farmers adopting things that are beneficial to them. Public sector is paying part of the cost. That's great. Um, but what happens is that practices, because they have this discretion of what to do, they're not choosing the practices that give the best social return on the money that's spent. So, um, farmer may put in no-till. No-till is good for them, um, um, and it's good for the environment too. But they do it because it's good for them. So we find that really expensive practices that would be good for the environment and cost effective from a social standpoint aren't adopted by farmers if there's not an addition to the farmer's bottom line. And that makes economic sense. That makes economic sense. So the practice selection means that we lose control of how our money is really used in this, and it's not used for the best purpose. There's also something we call an additionality problem. And you all probably, if you look at environmental spending here in Costa Rica, worry about additionality. And that's when you pay somebody to do something for the benefit of the environment, but it actually is something they would have done anyway. So if a farmer would be adopting a practice that's good for them, and then you come along and say, I'll give you some money to do that, well, they're really happy. They're going to do it anyway, but now you pay them for it. Well, you can't really count that as a pollution reduction because they would have done it anyway. So additionality is always a big concern when you're paying people to do environmental things. Now here is some examples of cost effectiveness of pollution control. This is for pollution that goes to the Gulf of Mexico from the Mississippi Basin. What I have here on the right side are the costs per pound of the pollution reduction. This is nitrogen pollution, which is a big problem in the Gulf of Mexico. On the left-hand side are various practices that can be used to reduce the nutrients. And there's two things to notice in this graph. One thing is that when you look across the practices going down the column, there are huge differences in the cost effectiveness of different practices. Some practices from a social cost standpoint are really beneficial, cost effective. You go down there and look at wetlands down at the bottom, 47 cents a pound of nitrogen in some places with wetlands. Look at other places, it could be way, way more expensive than that. So you have variation in these practices. You also have variation within practices. So the variation within practices comes from two things. One is where a practice is put in the watershed, because you put it up in Minnesota, 2,000 miles from the Mississippi Bay, so the reduction in nitrogen is very, very little because it gets used up as it goes along. So just that distance reduces the effectiveness of that practice. Also, so if you're close to the Mississippi, you have that practice, it's much more effective because it's right there on the Gulf of Mexico. So practice variation, so regional variation and practice variation. So if you look at these wetlands, we like wetlands. They look really good from a cost effectiveness standpoint. And we do like them, but farmers don't. Why would that be? There's no income from the wetland for farmers. Now they might like it, but in general, if they take the productive land and produce it, put it into, now that's not always good, but in general, that is what happens. So this is a case where a practice which is socially cost effective is not a private benefit, so you don't have adoption of that practice. So let's see, other limitations of the pay for practice approach. So it's a focus, this is really important to me, to focus on rather than the outcomes. So if you're a politician or a that, and you say, what have you done for the environment? And I say, well, I put in 1,000 hectares of this coal practice. how much do that reduce pollution? Well, we don't know. They don't. So you end up saying, let's focus on how we do it rather than what the outcome is. And that's what people say. And that's not a necessary thing. We can actually have estimates of how things do. The other one is that you kind of pull politicians to do and outcome is. So in some time we say, well, you know, we can do it. I said there were billions of dollars we spent. The USDA says, look at the billions of dollars we spent. One final problem with paying for practice is what is called. And so this is economics. So farms are complex operations. If you change one component of the farm, you'll generally change some other components. So when you do a practice on a farm, say for conservation, you may change another aspect of the farm that actually undoes that. So but the farmer goes over here and says, well, you know, that's kind of messing up this part of my activity. I need to do more of this. And so that increases the pollution by 5% from what it was. And so slippage is a big problem. This is instead of the European Union spends a lot of money, as does the US on practice. And this green graph there is the percentage of land that is treated under a particular European Union environmental program. Finland up there, they're treating over 90% of their land with this. Now, a study in Finland's doing great with how much of the eligible land was put in that treatment. But a study went back and looked at the pollution reduction that occurred, estimated by how what was done with other land that was not participating. Well, the other land was put into practices that were more polluting. So the result of this, so an unintended consequence is to increase the amount of pollution or not to reduce it as much as you thought of. So again, the voters aren't doing what they need to do. And this is because you focus on what practices rather than what you do in terms of environmental outcomes. Okay, some other things, limitation of spatial targeting. So there's a rule that a lot of people use roughly for ag pollution, and that's that 20% of the land is sort of good. 20% of the land causes 80% of the problem. That's not always true, but actually it's often as an approximation true. So here are two left on the Baltic, right, Chesapeake Bay. The dark areas are the areas that are causing the pollution. Lots of light, way more light areas than there are dark areas. But in both cases, the money for pollution control gets spread across all. So rather than concentrating the money in the dark areas, you spread it out. So you don't have the impact. You take the very bigger impact. You could take less money and spend it better and have a better impact. This is from a study I did on the Chesapeake Bay with colleagues. When you did a cost-benefit analysis of putting in these control practices for three pollutants and three watersheds in Pennsylvania, and so we actually benefit, not benefit to see the Chesapeake Bay. So so you have those two benefit rows, and you have the cost of the reduction row, and you have a net benefit row. You see, relative to these areas, enormous net benefits. These are annualized net benefits. So from these small watersheds, Mahandango Creek, we get 81,905 net benefits, a benefit cost ratio of 276. That's enormous. That's huge for a benefit cost ratio. Well, if you look at that range of benefit cost ratios, what would you say? You would say, if I'm going to spend money, start with Mahandango Creek. You get big benefits relative to cost. You know, you go next to Conewago Creek. If you got more money, go there. If you got more money, you go to Spring Creek. But it's just telling them where you spend your money matters a lot to your costs and benefits. There's another interesting thing about this particular table. Most estimates of the net benefits of pollution control policies in the U.S. from all show negative net benefits. We spend more on pollution control in terms of cost than we get back in terms of benefits. And that's because we waste money in the way we go about it. We could do it better. So that lesson is a general lesson. So this is a very unique graph because what we did is we estimated cost, minimized, so we get the most bang for the buck in terms of water quality protection. I mentioned to you before, multiple objectives are a feature. They're also a problem. And the problem is that, you know, benefits and they, you know, but sometimes that's just a good waterfall. And a very important example, no-till. It's actually a great soil conservation practice, very soil on the land. But it turns out that in some places, no-till is actually detrimental to water quality. An unintended consequence, but also you see in our policies, ag and food policies, and um, you know, studies show ag pollution control is very low cost versus to spend your money on ag. Okay, consequences, limit effectiveness, talked about that. Wasted returns, we can talk about that. So again, more of the same for something new. And, you know, my view is because of the power of agriculture, paying agriculture is politically the way it has to be done. And you can argue about whether that is right or wrong, but I think politically it's just the way it is. And I think over time you can move towards more regulation and people. But I tend to focus on approaches where you pay agriculture, but what I would ask is how you do it better. And we have lots of policy instruments for agriculture, and I could go into great depth. Some issues that are in this graph that I have, right across the top, compliance mechanisms, compliance base. Compliance base is what measures pollution. I say measure pollution. Compliance mechanisms, that's how you do it in some ways. You command, you provide incentives. Under the compliance based tax performance, I mentioned that. And then property rights are an important issue. To grant property rights to polluters, which is, say, pay for practice, or to uh, provide property rights to the environment, which is, say, polluter pay. So you have lots of options, and I have these little boxes with stuff. I think when you think about what are the essential things you have to do, and I think going to the essential is the essential thing to do because it's the essential things we really haven't thought about. So the most essential thing, you got to focus on what the water quality outcome is, what you do for the environment, rather than what practice you um, so there's lots of reasons why that is, but you really have to focus on the practice. The next thing is spatial targeting. So that means when you're spending money or devoting public resources for administrative enforcement or other things, you got to target on the places that are the big problems first. Start with the high priority places. Another one is the what I would say is single objective instruments. Co-benefits are great if they happen. That's great. But if you're worried about water quality, choose your policy for water quality first and foremost, because that makes you accountable for that outcome, and to choose the things that will make that outcome happen. So, and we have this principle in economics called the Tinbergen principle, and that says for every goal you have, you ought to have a practice for that one, a policy for that one. And once you start mixing things up, this kind of can make a bubble of what you actually have. And so that is another one that I think is essential. And then my last one is the integrated point and non-point pollution. This has been a focus of my work. I worked a lot on the trading of pollution between point sources and non-point sources, which I used to think to be the way to go. I still think it has great merit, but in the U.S. it will never work because of the nature of our water quality laws. This never happen, but you see it happening in other places. A great program in New Zealand where they trade pollution that includes that. So the way forward, what would I do? First thing you have to have is political ambition, and that means rather than saying it's great to spend money, even if it doesn't have an impact, things have to be done that cause pain someplace. Because it's got to be pain someplace if we're going to make progress. So I think the whole approach has been to try to achieve environmental objectives without somebody bearing costs that they notice. And I think we have to go someplace where costs are being felt and costs are leading to outcomes that we need to have. The next one that I think is essential is place-based multidisciplinary research. So ag environment problems are heterogeneous across states. They vary a lot. Social systems vary a lot. Economic systems vary a lot. And I think the number one thing is you cannot say that the best thing for some watershed in Costa Rica is the best, same as the best thing that's for the Chesapeake Bay or some watershed in Pennsylvania. There's too many differences. So you have to figure out what works for you. And there's multiple dimensions of what works. There's technological aspects. You need to have the engineers. The water scientists tell you this is what you need to do for this problem. These are the practices help you out. These are the results you need to kind of answer. So you have to do that. But as Juan mentioned a minute ago, there are behavioral science issues that are crucial, and if you don't address those, you don't address the problem. What is our problem? We didn't address the behavioral science problem at all. We assume that people are going to go do what they're going to do, what we want them to do, if we give them money, and they didn't do it. They did what they wanted to do with the money, and we gave it to them. So you have to think about the behavioral responses that will come. You don't want to have additionality problems. You have to do things that eliminate or reduce the possibility of that. Slippage problems are predictable. So slippage is simply saying that if you pull one lever on a farm, the farmer's going to go pull some other levers. Well, you need to anticipate what those levers are going to be. How do you do that? You look at farm modeling, you do behavioral to understand how the economic responses of policies will be on farms, rather than just saying, you know, if we put practice A on field B, we're going to be good. Well, actually, when you put practice A on field B, farmer's going to do something else. Local policy innovation, I think this is really good. In economics, we have in practice, the world is more complex. So you have to figure out what works within your context. And a lot of times, and I have found this, local people can come up with better solutions than national consultants. And so we have examples in the US of programs where a local watershed manager says, we have this problem, we need to do something about it. And this person heard that water quality training, is a great way to do it. So this person develops a pollution trading program that they think will solve that problem. Well, it turns out they didn't know enough about pollution trading to know how to set it up. They set up something else, and it turned out that something else worked great. So people can discover things that work, and so they'll work with the constituents in their area. They'll work with farmers because they've got to make the farmers happy. They'll work with make them happy. And so you find out what kind of compromises you need, what will lead to the things that you need. And that's not an easy task, but I think it is something where local policy innovation is the essential thing. I don't think that national government should design pollution policy for small places because they just don't know enough or have local politics that you need to figure out exactly what you need to do. So I think that you need national resources to help you with the technology, economics, things like that, things in modeling tools, tools. But when it comes to finding that work, it's really important to do the things at small scales where people get involved in it. And again, going back to that 80-20 rule, you know, if 80% of the problem, then you need to figure out how to work with that 20% to solve your problem. And then I guess finally, you know, it is, if you're going to pay the farmers, you got to come up with the money. And that's probably one of the biggest barriers because money is scarce. So thank you very much for listening to my talk. I enjoyed it very much. And again, it's a great honor to be here with you.
Thank you for your presentation, Dr. Shortle. For the next 20 minutes, Dr. Shortle will answer questions. Please raise your hand and our staff will help us by giving you a microphone. For those joining virtually, you can submit your questions through the platform chat. Let's begin.
Thank you. It was a really very nice and informative presentation. I have a couple of questions. The first one is, you said that whatever you have seen this apply and paying for practice. In Costa Rica, maybe it's your first place. So at least here, I don't see that's happening in the next years. Actually, in the last decades, the expenditure for agricultural sector have been decaying constantly. So I have two questions. The first one is, if you see this like a hybrid model points into a transition that in the future one can implement the painful practice? And the second question is that according to your experience, is the same that have been implemented for small farmers and for big farmers? Because I listen from Costa Rica, I think that will happen or will be more effective for small farmers than for big farmers that have thousands of hectares. And we have a really big problem now with water quality concerning agriculture and many other factors. So this, I think, is really important and really up.
So I believe hybrid models that entail transition is the way to go. And I believe that's true almost everywhere. Um, so, so if you have an extreme over here of voluntary pay for practice approach, then have to find a place in the middle that works. And so, partly it depends on where you start from. So if you start way over here on this extreme, it's going to be hard for you to get out of that extreme to go over here. You know, if you start a little bit farther over, it might be a little bit easier. And then you got to decide how far to go. It's going to be some far on one side or too far on the other side. You got to figure out where to go. But it is a learning thing and it's adaptive. And one thing you find, I mean, I didn't talk about this, but the level of unknown unknowns when you look at pollution control and agriculture is very low. So we have lots of studies that, you know, that will estimate how different kind of practices will clean up pollution, how locate them on the landscape will affect pollution. And often they're done with modeling studies, and then you do empirical studies and you learn we don't know what we thought we knew. And so you discover, it's a discovery process, like anything. No-till planting has been recommended in the US for decades as a way to improve water quality. It reduces soil erosion, it can reduce other things, but it can actually increase some kind of pollutants. That was a discovery because we have water quality problems happen. So there are going to be mistakes made. I think the thing that we do is we give received wisdom too much credit sometimes. Because we use a model and we like that model and we figure that model's really good. It's reality. Nope, it's not reality. That model's going to make mistakes. We have to be modeling with knowledge that our models will make mistakes. But I think even bigger than technical model mistakes are behavioral economics mistakes where we just misunderstand how people would respond to things we do. So we're not going to do, we can't put everybody in an average and figure out what they're going to do. We have to learn by doing. So I think, moving on this, the hybrid thing is important. And I think that's part of why I think this local innovation is important. Is learning by doing. If watershed A figures out things and watershed B doesn't, then you learn, watershed A has some good ideas and you can learn from those ideas. That's why another reason I don't like national approaches because it reduces experimentation. On the big farm, small farm thing, there should be bifurcation of farms in some ways and how you treat them for that. So I think we're happy to pay for practice when we're saving smaller farms from oblivion. We want to keep them in business, we like them. But I think when you get into large farms, I don't know why, apart from political things, we would want to treat a huge industrial farm any differently than we would want to treat any other kind of industrial pollution. So that's a hard thing to do. And how do you divide between the regulated, highly regulated ones and not highly regulated ones? So in the US, we had developed rules that you fall into the class of the regulated ones when you get up to a certain size. It's an arbitrary rule that can change. But I do think that it is, if that was the question, that a bifurcated approach is important.
Thank you, Dr. James, for your presentation. I would like to ask you about that. You say that no-till has, this is an implemented practice, but it can be detrimental to the environment cost. But from my understanding, no-till also benefits because, well, in our country, we have a lot of clay. So when the clay goes to the river, it can, how to say, take the water level from the, so it's less space for the for the for the life, and also some of the clay can have really consequences from diminish the levels of oxygen in the water, and also well, we have a lot of dams, so yeah, you keep you keep sedimented the dam, it can detrimental from a lot of perspectives. So I want to ask, so even though no till is really no environmental, like a good environmental practice, or is that not does not make so great as previously say or in the past has said?
So um, a fun question. And it shocks people when anybody raises the notion that no-till, at least it often does, is that no-till might not be entirely beneficial. So, so no-till is without a doubt a very good practice for many reasons. Farmers like no-till because it saves them labor costs, it saves them energy costs. So they like to adopt it, and we don't have to pay them much to get them. Most of them will do it voluntarily. When you look at it from an environmental perspective, so this is a good question when you're looking at agricultural or other land sources of pollution. You have multiple pollutants, multiple types of environmental consequences. So one environmental consequence is sedimentation. So no-till keeps the sediment from leaving the land, so it doesn't go to the reservoir and fill up the reservoir, or it doesn't go to the stream and cause a bunch of problems in the stream that it can cause, harm to fish, as well as clogging up the stream so it doesn't run around, things like that. So if that's your problem, no-till is great. And so in the US for a great many years, sediment from erosion was considered the #1 water quality problem. We had a revolution in the US of adoption of no-till because farmers liked no-till. So, started using it in the 80s. And when you look at the pollution reductions that came to the Chesapeake Bay, there have been some reductions in soil erosion. They don't come from public policy. They come from voluntary adoption and no-till by farmers. So when you're looking at the multiple pollutant thing, say sediment, good, reduce sediment. So then it becomes an issue. Well, you do use more pesticides with no-till, and that may be an issue, depending on the system. But the other thing that happens with no-till that has been recognized later is that you could increase the amount of nitrogen that flows off the land because of the way that you influence surface flows of water. And you can cause buildup of phosphorus. Now, I am not a soil scientist or ag engineer, so if I get the words wrong, forgive me. Or if I get the technical details wrong, but you build up phosphorus in the upper soil, and when you build it up enough that you can actually have it go into solution. So then something that would have taken years to move from the farm to the water goes off, just nitrogen goes off in solution, goes much quicker. So that has been found. That was the problem that occurred in Nigeria that was, public sector's been recommending no-till for all these problems, and look what it did. Another example, I gave you that study, numbers on cost effectiveness for the Mississippi River. When they did that study, they purposely excluded no-till from the practices for cleaning up the Gulf of Mexico from nitrogen in the Mississippi Basin, because their estimates said that no-till would increase the nitrogen that went into the Mississippi, so it was not included. So it's going to depend on which, and everything you said is right. So it's everything, it's going to depend on which pollutant you have to manage. This is one of the complexities, technical complexities of ag, because you have multiple types of pollutants. You have different environmental pathways that they could take. So if you look at nitrogen and go in the atmosphere, where it can cause particulate pollutants, then come down and go back into streams. And so how all this happens is very complex and daunting. And again, rules, part that. And I'm sorry if I over said what I said about it.
No, excellent. And just one second question, the last one. From the presentation that you put, like the nutrient pollution reduction cost in Mississippi, in the Gulf of Mexico, you put that the wetland, it goes the least cost per pound. But maybe I didn't quite catch the information, because for me, making a wetland is the highest of the practice, because you have to move land, you have to pay for the bulldozer, you need to go extract it. So where the number come from? That is the bottom line in the cost.
I take no responsibility for those numbers. They're not mine. But they came from a U.S. Department of Agriculture study. And so, yes, there are costs, and some things are very, very costly. But if they give you a big nutrient reduction, then your cost per pound can be very, very low. So even if you have to have those bulldozers and other stuff, if you get a lot of nutrient reduction, you're doing really good. Another example is, very popular where I live is riparian buffer. So riparian buffer. No farmer will do that on their own unless they have a strong social orientation. There's no economic benefit. There may be some altruistic benefit, but it's really good from an environmental standpoint, because the cost per pound of reduction is very low compared to things that are costing money. So how much reduction?
Well, thank you very much, Dr. James, for your presentation. I have a question that I think is the 1 million question. How do you think is the way to finance this kind of incentives? Because right now in Costa Rica, I think agriculture is facing an urgent matter, because our forest coverage has reached almost 60% of the entire coverage in Costa Rica. So the other 40% is agriculture and urban areas, right? So the pressure is going from urban areas into agriculture. It's changing the land use. The people is moving into infrastructure. The forest is protected by the law, so it's not going to change. The deforestation rate is very, very low. So the agriculture is the one that is suffering, right? We know that they contaminate a lot. So what we are thinking is that we have to do what you are doing right now. We have to reach that kind of recognizing them, what they are doing well, doing these good practices, right? The main problem is how we finance that in order to recognize them that they are doing that. and that they are providing ecosystem services by doing that, like the wetlands. Okay, and maybe it's not very attractive to landowners, but if you can convince them that they are providing ecosystem services, so that there is a value in there, that will be a change in the mindset. So that is the big question. How is the United States of America financing this land use change into best practices? And do you think it's viable way to put that into Costa Rica like that we are doing right now?
So, your question is probably in general the number one question for the problem in most places. In the United States, we do not have, now people will tell you we have a shortage of money because of the way we spend the money. We don't spend the money effectively. But I believe if you took the money that we do spend and used it in the better ways that I'm suggesting, then we would accomplish everything we need to do, and we might even accomplish more. So we don't have a shortage of money. We have a shortage of inspiration for how to go about spending the money. And so, you know, those billions I showed you, there's billions of dollars out there, and the farmers are happy to take the money. So it's a question about how to spend the money. And so I think though, when you move away from the rich place, then the money's scarcer and the questions are harder. And I think that that is one of the challenges that many places face is we need the resources to address this problem. So one way to do it is you begin to do more regulation than you would do otherwise. But you know, that's moving this way in mind. That's hard to do. The other way I think though is to think of creative ways, and people in the U.S. have done this because the money we spent hasn't gotten what we need. People look for new financing. The water quality trading pollution trading became a popular thing in the U.S. because people thought that sewage treatment plants would pay farmers to reduce pollution, but they don't, because it's just too complex. It's complicated, results are too small, and the regulations don't help it out. But I think there's other cases where, you know, you could use ways of, say, getting, I don't know if this is something to do here, but we could say, get the sewage treatment authority of San Jose and Alajuela and Heredia to pay farmers to reduce their pollution. So rather than having it come from the national government or the state government, we begin to get, because, you know, if there's a way to save, you know, money for the municipal sewage authority by having them have farmers reduce their pollution rather than reducing the pollution itself, that could be beneficial. That, you know, so you could look at opportunities for win-win situations of that kind. So that would be one thing. And, you know, certainly we should look for a portfolio. So another part of a portfolio would be payment for ecosystem services system where, so this is something they're looking at in Australia. They have the Great Barrier Reef. Great Barrier Reef is being harmed by sediments and nutrients that come from sugarcane land and banana farms in Queensland. And so they have been developing payments for ecosystem services that are privately financed. So they have developed an exchange in which Qantas, for example, could buy nitrogen reduction credits from farmers. They go to this exchange, and the exchange is working with farmers to install practices to reduce nutrients. And then Qantas hopefully will pay for it. That, so right now in Australia, this is a big experiment they're doing, hoping that they can use essentially private mechanisms to pay for the reduction in pollution and partly they're looking at offsets too. But so I think that's the thing that the deal. But what do they have? They have the Great Barrier Reef. So they have an iconic resource that they can kind of sell. And so not everybody can do that. But I do think it is the creative thing that has to be done. The other thing is maybe not make the scale of problems. If you're looking at the Gulf of Mexico, you have millions of farmers who contribute to that problem. That's going to be a huge problem. But if you're looking at, a small watershed that doesn't have a whole lot of farmers, you does have some people, you might find ways that might be utilized within that context. That's what I was saying when I talked about local innovation. You might be able to find things that work in a place, well in that place, that will solve or help solve the problem. So I don't have an answer. I think we have to quit looking to traditional means to look at novel means.
Water quantity and quality. From, pollution from urban point sources, but also non-point sources. But the thing is, here, the agriculture sector doesn't want to recognize that. There is a resistance, a very strong resistance. Even they don't want, for instance, to have a new water law. And if we have a new water law, diffuse pollution should not be included in the law. And that is a condition to approve the new water law in Costa Rica. It's a condition, what for me is terrible. And at this moment, I think, we have problems with nutrients, but mainly for pesticides, residues in the water. And we have already, let's say, more than like 15 years ago, we have a pollution from point sources, water sources for to use for water potable for the population. In the Caribbean side, polluted from Bromazil, and then in the north side of Costa Rica, and like 1 year ago from chlorothalonil. But we say just one molecule of pesticides, but there are many. Those were the molecules that where appear higher concentration that the one is accepted in our regulation. And if you see how the point sources, water sources are surrounded from agriculture, it's incredible. Even we have a law, a forest law that define and not the forest law, but also our water law that is from 1942 that defined a conservation zone to protect the water source, and nobody fulfilled that. So how really? You mentioned that we should promote and it should be something integrate, but there is some resistance. And as you say, it's not only here, it's around the world. It's not easy. And the agriculture sector is the one that use more water in the water, 75% of the available water. At here in Costa Rica, the same, 75%. So it's not easy. That's why we are here, because we wanted to hear you and to know some other experiences, but I know it's not easy at all.
It's not easy. You find pockets of improvement in places. And I think generally what happens is you get communities that face a real problem, and then you develop local leadership that can solve that, that's dedicated to solving that problem, and then you can get things happening. I think that's from most water quality protection from industrial and municipal came from the top. I think when you're looking at, and that's because the problems are nationwide. You have treatment plants everywhere, and you have industry and but when you look at land-based pollution, it varies so much from place to place. So you have to figure in our approach what might work. So I don't think it can come from the top down. I think it has to come from the bottom up. I think in the US, we have had no innovation, environmental innovation in water quality protection since 1972. And we haven't solved all of our problems. And our Clean Water Act is a sacred document. Nobody will touch it because it's a sacred document, but it's not solving problems. So the federal government can't be depended on to solve that problem. So you have to have, I think, and doesn't say it'll work, but I think bottoms up is the way that I would generally try to approach those problems. And some are not amenable. If you're looking at a massive problem like the Gulf of Mexico, it's too big for bottom up. But if you're looking at other ones that are, and in Pennsylvania, I started a conference series in the mid-2000s. So mid-2000s, I had that diagram where 2010 EPA came and said we're doing a terrible job and we really need to do better. I knew that was going to come. So I started the conference series in Pennsylvania in 2008. We tried to get farmers to come up with new strategies for agriculture. And we've had this conference. I quit doing it myself. I turned it over to other people. But every 5 years since then, the people get together. And it's really been an interesting evolution. It's always focused on getting people who were not cooperating to cooperate, to talk to each other and saying, we have a common problem. How do we address the common problem? And so rather than going like this, how do we shake hands and move forward? And I won't say it's succeeded in every respect, but it definitely has got people talking collaboratively about how to move forward. I think one of the interesting things is that the farmers are actually saying, we need to begin pointing fingers at the farmers who aren't doing good, because they're making it look bad for all of us. And so you see movement within that agricultural community of farmers who wish to do things in new ways. So I think, nothing, I think that a lot of things can happen fast. Some things can happen fast. So we have to change attitudes. But, I don't think that. I want to thank you all very much for coming, and thank you very much for your really good questions. I enjoyed them very much. They're good questions. And I want to thank you for listening to me in English. So thank you, and asking good questions in English, so somebody understood me. And I would try to say that in Spanish, but I won't.
Well, with this answer, we conclude the question and answer session. And we cordially invite you to a coffee break outside the auditorium. Please return here at 10:50. We changed a little the agenda, right? 10 minutes, and please return here at 10:50. Thank you.